Okay.
We're good.
Example K. So I have the square root of 98 minus 2 times the square root of 32. Yes, Jalen, what's your question? Well, after this one is an addition one, and then there's a mixed addition and subtraction one. Yeah, and then those are the only 3 examples for this. Well, for this, sorry, this portion. Yes, ma'am. I'm going to show you. Okay, I'm going to show you in a second, once we are all ready. Because this is fun for me. Okay, so I have the square root of 98, and I have the square root of, 2 times the square root of 32. Are my roots the same? Yes, they're both square roots. So that part is a check. I'm good. Are what's inside the square root the same? No. Here I have a 98. Here I have a 32, which means I can't put those together. So what I'm going to need to do is see if I can break the 98 and the 32 down so that what's left under the radical is the same, and then I can combine like terms. So I need to think about what multiplies together to get 98. Anybody have an idea?
32.
49.
49 times 2. That's the best one I've heard. What about what multiplies together to get 32? Just out of curiosity. 16 and 2. Are we seeing a pattern?
No.
So what I'm seeing is that when I broke 98 down, I broke it down into 49 times 2. And I know 49 is the same as 7 squared. Also, I know that 16 is the same as 4 squared, which means that the square on the 7 is going to cancel out with the square root that's currently around it, bringing that 7 outside. The 2 is going to stay, though, because it doesn't have an exponent of 2 on it. I notice the same thing's going to happen with the 4 in my second radical. It's going to come outside, and the other 2 is going to stay under it because it doesn't have an exponent of 2. I'm going to simplify by putting the 2 and the 4 together because I don't want 2 whole numbers out there. So then this becomes 7 root 2 minus 8 root 2. And now I have identical values underneath my roots, which means that I can put them together. So when I combine these, I'm only combining the whole numbers and then putting that radical with the answer. So what's 7 minus 8? Negative 1. So this is negative 1 times the square root of 2, which is just negative square root of 2. And then that is this problem simplified. How do we feel about that?
Is it all right if we just leave the 1 up front? Like negative?
Yeah, absolutely. They're identical answers. Anybody super confused by what I did? Okay, so I was just breaking them down to see if I could get them to have the same radical. If I could put them together. If not, they have to stay separate. So let's do an addition problem.
Is there one that we like that where we can't simplify?
There's not going to be any that you can't simplify at all. There's going to be some that won't combine, but they'll still simplify down at least a little. So this is L. 4 times the square root of 8 plus 3 times the square root of 50 Are my roots the same? Yes or no? Yes, they're both square roots, so I'm good there. Are the values beneath the roots the same? No. This one has an 8, that one has a 50. So I'm going to have to break it down to see if I can combine them. What do I know multiplies together to get 8? 4 and 2. Why didn't I choose 8 and 1? Okay, because 4 is a perfect square, and I know it's going to cancel out with my root. So we always need to be keeping that in mind. I'm looking for values that will cancel out the root I'm currently under. So this square root of 8 becomes the square root of 4 times 2. What about the 50 over here? Can I break that down at all? 25 and 2, good. Again, I recognize that 25 is a perfect square, which is why I didn't want to break it down into 5 and 10, because neither one of those are perfect squares. So 25 and 2 is perfect. I'm going to then rewrite the 4 and the 25 as the squares that they are. So 4 is 2 squared. 25 is 5 squared. You don't have to do this if you recognize that we can just take the square root of those. I like to do this so you see exactly what's happening. So now I see that because this is 2 squared, the squared and the square root are going to cancel, bringing that 2 outside, leaving the solo 2 underneath the radical. Same thing's going to happen on my second one. The 5 is going to come outside, leaving that lonely 2 by itself. I go ahead and multiply the whole numbers together. 4 times 2 becomes 8, leaving the radical 2 there. 3 and 5 becomes 15, again leaving the radical 2. And then I add my 8 and my 15 together and put the radical with my answer. So it's 8 plus 15.
23.
So this becomes 23 root 2. How do we feel? Okay?
You gotta add anything else on top of this? Yeah, it's good.
You know me too well.
Y'all need to stop asking.
If you ask,
She's just gonna show it. I mean,
I am going to show it anyway, so it doesn't matter. Any questions, concerns, or issues on K or L here? Yes, Shane. 4 and 25 are both perfect squares. Square roots. Yeah. But those are whole numbers multiplied into the root. If it was like a little 4, then it'd be a 4th root. You're right. Yeah, those are whole numbers. Sorry, I could put a dot in between to clarify that if you have any issues in the future. I will try to do that, okay? Let's go ahead and do example M.
Work from right to left.
We work from left to right typically, yes, just like we read a book. First thing I need to check, are all 3 of these the same root? Yes, which means if I can get them to simplify far enough, I can put all 3 together. No guarantees, but it is a possibility. Do they all 3 contain the same value under the square root? No, so I know I need to simplify.
if it wasn't the same root, would you just be like, no, like that's
If all 3 are different roots, there's no possibility of simplifying or putting anything together, so I wouldn't even try. If 2 of them were the same root, but one wasn't, I could still try to put them together. Yeah, but we check just to see what the possibilities are. Okay, so what I need to do now is see if I can simplify these radicals until the same value is underneath them, right? Awesome. How do I break 12 down? 4 and 3, awesome. So this is 5 times the square root of 4 times 3. This is important because 4 is a perfect square. What's the square root of 4? 2, so that 2 is going to come out front.
Oh, okay.
Do you want me to go back and do the other stuff where
No,
I
I
do 2
was-
squared and, okay. And then of course that simplifies to be 10 root 3. I can't do anything else with that term, so I move on to the next one. What can I break 27 down into? Why couldn't I do something in 2?
Odd number.
It's not even, first of all, and I'm trying to see if it can match this 3 that I have left, because then I can combine it. So I recognize that what times 3 is 27? 9. Which is perfect because 9 is a perfect square. What's the square root of 9?
3.
So we bring that out, and this becomes 2 times 3 times the square root of 3. I can put the 2 and the 3 together to get 6 root 3, and I have to maintain my operation of addition between the two terms. Are we okay so far? That was 2. I have 1 more. So now I need to look down at that negative square root of 128 down there. And I need to ask myself, okay, what can I break 64 down into?
64.
Oh my gosh, 128.
Yes,
64 and 3.
8 and 16.
Oh boy.
64.
What's the first thing I should check for?
I did that. And I got all that.
Well, what number am I trying to get left under the radical? So I should try 128 divided by 3 first, just to see. Does it come out to a whole number?
No.
So I know that means I'm not going to be able to simplify it down to a square root of 3 left, which is okay. That just means I won't be able to combine it with these 2, but I can still simplify it. So instead, I'm going to break it down some other way. So what do I recognize multiplies together to get 128?
64.
I heard 64 and 2, but I want to try a different route just because we might not all recognize perfect squares when we see them. What's another thing that multiplies together to 128?
32 and 4.
What do you say? 16 and 8 or 30? I like 32 and 4. We're going to try that one first, okay? Just because I want to show what happens when we don't immediately recognize the perfect square.
Well, that's gonna be me every time.
So we recognize that this is 32 and 8, right?
Yeah, or 32 and 4.
32 and 4. Okay. So I'm going to switch that around to 4 times 32. So I recognize that I can break 32 down, or oh my gosh, 128 down into 32 and 4. I know that 4 is a perfect square, so that 2, that is the square root of 4, is going to come out. And I'm left with the square root of 32. I also recognize that I can probably break 32 down farther, right?
Yeah.
What multiplies together to get 32? I heard 8 and 4 again, so that's the one I'm going to go with. So then this becomes 2 times the square root of 4 times 8. And again, I recognize that 4 is a perfect square, so I can take its square root and pull it out front. What's the square root of 4? 2. So now this becomes 2 times the square root of 8. That 2 times 2 is going to become a 4. So I have 4 times the square root of 8. Again, I don't think I'm done simplifying this radical. What else comes out of 8? Or what can be multiplied together to get 8? 4 and 2. So now this becomes 4 times the square root of 4 times 2. Again, I recognize that 4 is a perfect square, so I can take its square root and pull it out front. And I get 4 times 2 times the square root of 2. That is as simplified as I can go here, because square root of 2 can't simplify anymore. So I can put the 4 and the 2 together, and I get 8 root 2, and again, I was subtracting between the second and third terms. So that means that square root of 2 is never going to combine with either of these 2, and that's okay, because I can still simplify by putting these 2 together.
Wait, can you take the 8 and put it together with the rest of them or no?
No, because it's attached to my square root of 2. We can't separate terms. That's a good question. So let's put the 10 root 3 and the 6 root 3 together. When I add them, what do they become?
16.
16 what?
16
Square root of 3. Good. So now I have 16 square root of 3 minus 8 square root of 2, and that's all I can do. How do we feel about that one?
Oh, look at that.
Would you gotten the same thing?
I wanted to show the longer way, essentially, if we didn't immediately recognize that perfect square. Because sometimes we don't, and that's okay. Questions, concerns, or issues? Let's switch gears a little bit. I think we've kind of run our course with addition and subtraction, so let's try some multiplication.
Can we do multiplication?
We did.
We did, but now we're going to do it a little differently.
Oh,
yeah, dude.
I don't think it's any harder.
It's we already did all this.
It's fine. We're like sticking together, I guess, already. She said. That's weird.
I don't remember how to do
I see you different, and I
see
see
mine
I've never done, I think, more than 26 examples on something. If I did, I'd start using Greek letters.
Huh?
That'd be
Alpha,
fun.
beta, theta, whatever.
Yeah.
I just put EX in front of everything.
That's okay. Okay, so here I have two expressions being multiplied together. How am I going to multiply these? Well, I know ideally I need to get them down to the same radical, reduce, try and combine them, but how am I actually going to do that? What has to be my first step here? Oh, I heard it. I can FOIL, because this is a binomial times a binomial. So more than one term times more than one term. So we're going to FOIL this bad boy. Shush. I'm going to color code so we can remember exactly how it works. So F in FOIL stands for first terms. So we're going to multiply those two first terms together. Remember, when we multiply radical terms, we multiply the whole numbers, and then we multiply what's under the radical. We have to ensure, however, it's the same radical. If not, we can't combine them. Each of these are a square root, so I'm good to go. So 4 times 3 becomes 12, and 3 times 2 becomes the square root of 6. So that was my first terms. Then I do my outside terms. So I have 4 times the square root of 3 times negative 6. There's no radical there to worry about, so I just put the whole numbers together. 4 times negative 6 is negative 24, square root of 3. Then we do our inside terms. Again, I have to ensure they're both the same root, and they are. They're both square roots. So I multiply the whole numbers together to get positive 15. And then square root of 2 times square root of 2 becomes square root of 4. And then I do my last terms. So 5 root 2 times negative 6. Multiply the 5 and the negative 6 together to get negative 30 root 2. And then it's all about simplifying from here. Oh, no. Undo. Where's the undo button? It's gone. Wait, I can move that. No, we're good.
Oh, boo.
I about cried.
Where's the undo button?
I just thought it was gone. Okay. So from here, I need to simplify by, of course, combining like terms. So have the same radical, have the same value. But I can also see if I can simplify any of the terms first. Do we see any that will simplify before we combine? What are you thinking, Brandon?
4 in the six, right? So you can get rid of the thing. And I'll just go. You tell me every time.
The radical. Well, I can't break 6 down into a perfect square, so that's not going to work. The 4, though. Say, how am I going to break 4 down?
2 squared.
2 squared. I recognize that 4 is a perfect square, so I can break that down into 2 squared. So the squared and the square root cancel, leaving just the square root of 4, which is 2. So that square root of 4 here will become a 2, and that will allow me to simplify a little bit more. What is 15 times 2? 30. So I know that that's going to be some number in this expression equation. Is there anything I can put together from here? Do I have any radicals that are the same values underneath?
Wait.
Yes or no? No, so I need to look to see if I can pull any perfect squares out of any of these to simplify them farther. There's no perfect square I can take out of 6. There's no perfect square I can take out of 3. And there's no perfect square I can take out of 2. So this is as simplified as this one is going to get. So I just rewrite it having the 30 in there.
Really? That's all we have to do?
That's all we had to do on this one. I couldn't do anything else.
Oh, if I would have seen that, I would have tried something different.
Yeah.
I would have
Tried
tried
to
to
do
take
like
a
something
6
with
out
the
and try to do something.
Right, no. Like we could have taken a whole number 6 out, but we're not comparing it to anything, so we don't need to. How do we feel about that?
That was easy.
Let's do another one.
Oh, I was gonna say it was easy.
We are actually almost done. We're going to do one more multiplication, and then I'm going to show you another rationalizing, and then we're finished completely.
So we get
Yeah, until you get there.
So we get to the homework and we don't know how to do anything.
What time is it?
It is.
12:19. Oh, we got time.
No, we don't.
Wait, no, we don't.
Why don't you? Time to watch the video.
Right?
That'd be awkward, wouldn't it?
I'm actually excited.
Actually, what did
I don't carry embarrassment anymore. I've already embarrassed myself.
Xavier, talk me through it.
It's 12:20.
Yeah, that'd probably be a good idea.
I was too busy.
Yes,
Everyone's used to it.
Elijah, you look bored. You can talk me through it.
Last match went out.
What does that become when I multiply it together? Perfect. What's next? Okay. Perfect. Next. Awesome. And last one. Awesome. Pick the next person to talk me through the next step. Okay, Keaton, what am I going to do? Is there anything I can do with the way it is right now? No. So what do I need to see if I can do from here? See if any of them contain a perfect square I can divide out. Does 15 have a perfect square that I can take out of it? Nope. What about 6? Nope. What about 5? And 2? So we're done.
Okay,
I like that.
Yeah, let's do that. So 2 times 2 equals 4, so 4 is a perfect square. 3 times 3 equals 9, so 9 is a perfect square. So the same number times itself equals that number. That's a perfect square. 5 times 5 is 25. 25 is a perfect square.
Is this gonna be on board?
This? Yes. Okay, questions, concerns, or issues with multiplying radicals together. Okay, last little piece. So I know we did a little bit with rationalizing before when we had just a radical underneath. Now we're going to examine what we have to do when we have something plus or minus a radical in the denominator of my fraction. I know you're so excited. So for example, this is example Q in my notes. If you want to maintain like my list, if not, you can, it'd be P next, I think.
We have 4 problems.
We're not going to do them all.
So less than 4.
I'm not really
Oh, we're trying to
understand what these notes mean.
I'm gonna need to make like a cheat sheet like soon.
I should also let you know, you have, I think, 2 lessons left before we do a review and a test. I think the next lesson is going to be at least a 2-dayer, if not a 3-dayer, though, if I remember right.
Oh.
So it's not going to be like in 4 days that you have a test.
Ooh, yay.
Okay, so before, when we had just the radical underneath, to rationalize, I just multiplied by that radical. But it's a little bit different now because I have something plus or minus the radical. So we need to multiply by the conjugate. So we did talk about conjugates when we talked about complex numbers. Anybody remember what a conjugate is?
No idea.
Ooh,
Or you do the opposite.
what do you mean by the opposite?
Like, make a fraction so it would be 2 minus this one.
We change the sign on the radical here, just like we changed the sign on the imaginary number. So this one stays the same, but this one flips sign. So the conjugate of 2 plus 3, or 2 plus root 3, is 2 minus root 3. So that's what I'm going to multiply into both the numerator and the denominator of this fraction.
What?
You're just taking the opposite.
I'm multiplying the top and the bottom by the conjugate of my denominator.
Okay, so.
We just changed the sign in the middle. In the top, I have 1 term times 2 terms, so I don't have to FOIL. So what's 5 times 2? What's 5 times negative root 3? negative 5 root 3. In the denominator, I will have to FOIL, so it might help to put parentheses around these. It's your choice.
So did you?
5 times 2 is 10.
Okay.
5 times negative root 3 is negative 5 root 3. What's your question, Julie? Okay, so when we FOIL the bottom, 2 times 2 is 4. 2 times negative root 3 is negative 2 root 3. 2 times root 3 is positive 2 root 3. And negative root 3 times positive root 3 is negative root 9.
That's so confusing. So you multiply the 2, and then you multiply. Oh.
I just FOILed.
Why do that make so difficult?
Why not?
Because it's confusing.
What beautiful thing happens because I FOILed with my conjugate? My radicals cancel for the most part. So this one cancels and that one cancels. But I still have an issue here. I still have a square root in my denominator. Is it going to stay a square root? No, because 9 is what? The perfect square. 9 is 3 squared, which means the square and the square root cancel, leaving just the square root of 9, which is 3. So this becomes 10 minus 5 root 3 over 4 minus 3, which is 1. So it's just 10 minus 5 root 3. You can put it over 1 if you want to, but that's a little bit redundant, so I don't do it. How are we doing?
Amazing.
Do you want to do another rationalizing like this?
No.
I heard yes, so we're going to do it. It's just one more. You guys are fine.
I see. Yeah.
I said yes too. So it was like,
Good. I like extra examples. They're very helpful. Maybe I don't.
We all are linked.
How funny it would be if I actually secretly hated math.
I would not be good actor if that's the case.
So we got time to
Like
watch
somebody
the
needs to give you an option.
over and over again. Just watch. What?
Real curveball.
Wait, is that for that three?
As for shame.
definitely didn't have to go through the whole alphabet.
Can I
Me
rewrite
too.
that
It's
so
okay.
it's 3 minus? I'm gonna rewrite it like that so much easier.
First question I have, do I need to rewrite this so that the root 2 is listed second? So should I rewrite this bottom as negative 3 plus root 2? I could if I wanted to. It's not going to change anything. I'm not going to because it's not always going to work that way, but you are welcome to. Just know that that's kind of going to change the way yours looks compared to mine.
That's okay.
So what is the conjugate of root 2 minus 3? Root 2 plus 3. So that's what I'm going to multiply into both the numerator and the denominator of my fraction.
I think this crossed out.
No, because they're not identical diagonally. So we have to FOIL both the numerator and the denominator here. Oh my gosh. It's back.
Okay, so why can't we just cross out?
Because this is minus and that's top, so they're not the same.
You need to hold that clear button,
Sean,
like
no
on
easy
my
work.
drop down, so you don't clear it on accident.
I don't know if I can actually.
They should make it like that.
I feel like they should, or have like a protective barrier where you take it twice or something. That would work. The good news is I can just go back and it's there. Okay, let's FOIL this bad boy.
Right.
Oh my gosh,
I think I'm
look
done.
at me.
So I FOILed the top and I FOILed the bottom. I'm gonna give you guys a minute to catch up and check your work with mine. And then we're gonna continue on.
How'd you get the +4?
Square root of 4, because it's square root of 2 times square root of 2, which makes square root of 4.
Oh, I thought that was a negative sign.
No.
Well, that's why those are wrong.
So I think I got this.
Okay. So now we're just gonna kind of walk through the numerator and walk through the denominator
Wait.
in a second, I guess.
You wrote it backwards.
There is
I
a
still did it wrong.
problem, I think. unless
Did
I
you
just
switch
did it
these two?
wrong.
Then yours are gonna be a little different in the bottom.
Yeah, but
Yours
still-
not.
And in the top, because you multiplied by something different than what I did.
Yeah, it's -7.
Just wait till the answer.
You would have multiplied by -3 plus root.
Yeah.
No, you would have multiplied by -3 minus root 2, right?
I forgot.
So there's a
No,
problem.
3 minus
I
2.
drew a line.
You can't
Well, this,
have
if you changed it, would have been -3 plus root 2, which conjugate would have made this a minus. That's what you should have multiplied by if you had switched
Well,
those
that's
around.
why I did it wrong.
Okay. Okay, looking only at my numerator, is there anything that I can simplify or put together?
The square root of 4.
Square root of 4 is what? So that's a 2. What else?
The bottom.
Connor, what else can I do in the numerator? Well, I don't really, what do you mean by the 12 to 4 and 3, I guess?
Like break it up so that you change 4 to 2 squared.
Well, I don't really need to because I don't have a 4 under my square root anywhere, so I don't have to worry about that. But I did kind of like what you were thinking because you were looking at these two terms. What do I notice about those two terms? They're the same, right? Which means I can put those two terms together. What's 4 root 2 plus 3 root 2? 7 root 2. 4 plus 3 is 7, and the square root of 2 just stays there. So that becomes 7 root 2. And then I can put the 12 and the 2 together to get 14.
Does it matter which way's first, like the 14?
No, that's fine. Then, ooh. Reese, what do I notice from my denominator?
That's the 3 square root of 2, negative 3 cancel out.
Okay, what else?
The square root of 4 is 2 squared root of 2.
Okay, and then what can I do?
Minus negative 9.
And that becomes what? -7, yep. So what I have is 7 root 2 plus 14 over -7.
Is that it?
This is something that I expect you to look for in the future. I have a 7, a 14, and a -7. What do I know about all three of those?
You're all.
Divisible by 7, right?
Yeah.
So I can take that common factor of 7 out of all of those, and that will leave me with 1 times the square root of 2 plus 2 over -1.
Wait, I
Can't you divide?
And then I can just change all the signs by dividing the -1 out, and it becomes negative root 2 minus 2.
Wait,
Which you could reorder to -2 minus root 2.
Okay, wouldn't that root 2 have to be, have a sign underneath it at -7 because you divide that by 7?
I divided this by 7, this by 7,
Yeah,
and this by 7.
but you didn't divide the
Oh,
root
God,
2.
why did I?
Right, so I don't have to because I divided something it's multiplied by 7. Yeah.
No, wait, no.
Okay, how do we feel about this? Are we okay?
Yeah.
I would say, okay.
I just want to ensure that everybody's okay with this for the most part right now. So I'm gonna ask you to do a 1 to 5. 1, you have no idea what's happening in your life. 5, you could show somebody else how to do this. I wanna know where you are. Addison's a 4, good. Okay, so I don't really see any zeros or ones or halves. So that's not bad. So I'm okay with this. What I'm gonna have you do is I'm going to let you work on your homework right now, and I'm gonna try and get their video to pull up. Yes, go for it.